Okay, good morning, guys. We got had some people ask me about making a video about our universal robot, our UR5. We have it tied into our mini mill to do some parts loading on our fourth axis here. So I thought I'd make a little video about how the UR works and how I have it tied into the machine. And we'll get started. So the first thing, kind of an overview of the machine, of the robot, is you have your control pendant, the robot itself, and then down here is the robot controller. The robot controller is kind of just basically an industrial PC with some inputs and outputs, and the control pendant is the monitor and the touchscreen and everything. So we'll boot it up. Takes a few minutes to boot up, but while it's booting up, I can kind of show you some things. They give you a mounting bracket, which I just put on the side of our mill here. On the back of the control pendant is the only hardware button on the robot, and that's it's called a free drive button and a strap, and you can kind of put your hand through the strap and your fingers are right there at the free drive button. Free drive is what you use when you're programming it to move the robot with your hand. I can show you that. All right, so when the robot's booted up, you start with a dialog box here that prompts you to go to the initialization screen. This screen just is the first screen on the robot when it boots up. It's looking for a couple things. Mainly, you're just telling the robot to turn on, and it's going to prompt me to. It's showing a 3D view of what the robot position is, and you can kind of see that is an accurate representation. Once I click start, and I can kind of do both at the same time here, you'll see the robot kind of move. What it is it's releasing the brakes on each of the servo motors and kind of homing each one without really moving it all that far, but it definitely moves a little bit. You can go into program. It gives you an option of loading a new program or starting with an empty program. The installation, setup for tool center point, that is sort of like your G54 on a CNC machine. You tell the robot where the 0 point of what you're working with is. This is showing the, let me move the robot around here. All right, so I just moved the robot kind of up and sort of so we can look at different parts of it. This is the move screen. This gives you a view of the position the robot's in, gives you access to move each joint, and you can also kind of jog each joint or the tool center point. You can jog it relative to your 3 space here. So I'll go back to installation. So tool center point is something that I don't think it depends how precise you want to be. If you are kind of programming everything just by moving the robot into position, you don't really have to even use this. I have TCP1 set up, which would be relative to my gripper one. So it's negative 2.5 inches from the center point of this aluminum joint. So 2.5 inches up and 5/8 of an inch away from the face here. So this is about 5/8 to that from the face. And then I have an RZ is just a rotational relative to, I think this pin. There's an alignment pin right here on this aluminum that, so we're like 270 degrees off of that. So that's just gripper 1 is programmed that way. Gripper 2, it is, 180 degrees out of that, but we don't worry about that. We just program it the way, by moving it around. So I set that up, but I don't know that I really would have need to. On the mounting screen, they give you a lot of different configurations to mount the robot. They just want you to tell the controller which way you have it mounted that way. A lot of the joints are going to be working differently relative to gravity. So if you have the whole thing hanging upside down, you want to tell the robot that it's in that configuration so the joints can work against gravity differently. And that all comes into play with telling it how much weight you have on the end effector, and that all ties back into the safety system that kind of is inherent to the robot. This is your I/O page. You can set up different names for the I/O. You can see I have 1 digital input that's labeled, and I have 4 digital outputs that are labeled. You have a bunch of them. You have 8 digital outputs, another 2 that are wired through the robot, 2 analog outputs, and then a bunch of configurable ones. So I'm using like a quarter of the outputs that I could use. We'll talk more about that in a minute. Safety, there's a lot of safety configurations and options you can use. Sort of the general setup here on this page. If you look at the default, which is where I have it set, and it says intended to be used where people are aware of the robot arm and its payload, or when application has no sharp edges and no pinching hazards. So that's sort of just a measurement of how the robot is going to respond when it comes in contact with forces that aren't expected. If it's moving and it's constantly looking at the amount of force it's applying to get a job done, and if you put your arm in the way and it hits your arm, it's going to say that's more force than I think I should have had. I'm going to stop travel and throw an alarm, which is easily reset and you can keep moving. But this is sort of one of the main reasons we bought this robot, was because we don't have a big shop and we don't have room to put guarding up, and this is a lifesaver in the sense, well, probably literally, and also in the sense that you can just set the robot up and teach it a task, and you don't need to leave the area, and it's sort of aware of everything, and it's just one of the best features. Variables, you can set up variables for counting and doing calculations and other things. Don't really use that. Modbus, don't use that. Features is sort of a way to define planes and lines in space relative to the robot. You can see there's a couple set up. I have a mill table line set up and a parts rack. This parts rack here, I have it set up as a plane, and the mill table is set up as a line. I took the gripper and I touched it on 2 different spots of the mill table inside the mill. That gives me basically a line along my x-axis that I can move the robot, and it acts like it's in the same orientation as the mill, so I can move it parallel to the X, perpendicular to the X, or the Y, parallel to the Y, and I can move it to the Z. That's very useful when you're doing the actual programming of the work inside the mill. Conveyor tracking, if you have a conveyor of parts moving, you can program the robot to sync up with that if you have an encoder on your conveyor. And then you can have the robot boot up with a certain program loaded already. The move screen we kind of touched on. Those features, those planes that we talked about, you can call them up here. So if I have it set to mill table there, that changes kind of the appearance of the move screen, and all these moves are now relative to that line. So it's going to travel, along the line, perpendicular to the line, or perpendicular in the Z. So that's very useful. Again, you can move each joint rotationally here. You can put the robot in free drive by pressing that button. You can send it home. And then this is sort of a relative position to TCP1. Yeah. And then on your I/O page, this shows all of the inputs and outputs. These in yellow are safety outputs. If you would want to put guarding up, or a light screen, or like a area sensor, proximity sensor, you can tie that in there. These are the inputs for the general work, like parts done, or basically status indicators to the robot. The outputs down here are the robot's actually controlling the clamp of the A-axis in the mill, and then it's the two grippers on the end effector, and then this is for a shunt vise that goes in the A-axis that the robot also needs to control. You also have a digital output, two digital outputs on the end effector itself that you can plug in via this plug here. And you also have a couple analog inputs and outputs. That's pretty much it as far as the kind of the setup screens. This is a log. This shows your robot, the controller inside the controller cabinet, the temperature, the voltage coming out of the power supply, the energy used by the robot. You see it's like 36 watts, which is kind of crazy. The current it's drawing, and then this gives you a look at each joint, the temperature and the amp draw on each joint motor. So you can start a new program from this page, an empty program, or what we'll do is just look at one of the programs I'm using right now. So we'll load it in here. When you're programming, this is your program right here. We can kind of expand that. Yeah, so this is your program. The one thing that is helpful, and I kind of did it the wrong way to start with, is you always program your grippers and your work holding so that when the output is high from the robot, that opens the gripper. In other words, when the input's on, that is the only time the gripper's open. The default is closed. So when you pick a part up, you only open the gripper to get the part in the gripper. Then you shut that input off, the gripper closes, and you can leave that part in there. You don't have to worry about it falling out because it's only going to open when the voltage from the robot goes high, which is a good way of doing it because I can actually at the end of the day, shut the robot off, even though the robot's controlling the work holding, and I can shut the robot off and the work holding is good even if it's milling. It's just sort of a good way of doing it. So at the beginning of the program here, we have our two grippers. I turn the gripper 1 on, which means I open it, and I set gripper 2 as closed. Then this is a pallet operation here, this defines the parts grid that we have here. I put a little counter in here. If I only have, like today, I only have 33 parts there. So I'd set that for 34, and that would stop after we get 33 done, which is something that we use a lot. And then after you define the pattern sequence, you just have a bunch of moves. And the moves just tell the robot where to go and what to do. So a move J is a move where the robot can move each joint to get to the final position, and they do it all at the same time. And that gives you sort of a sweeping motion with the robot. And I can kind of show you what that looks like. So it's going to do, if we go here, and we go to the top, your controls are like a play and a pause, and sort of the next track button here skips to the lines in the program. So if you hit play, it says move the robot into position. You can click manual and move it physically into position, or you can click auto. When you click auto, I'm gonna click it, you can see the robot is moving sort of in a sweeping motion, and it gets into position to start the program. That was basically a move J. A move L is moving in a line. So it takes all the movements into account to move the end of the gripper in a point-to-point line to where you need to go. So if we go, I'll close this. Program structure editor, so that is basically all your moves that the robot can do are here. Under the basic tab, you have move, wait, pop up, which is a dialog on the control panel here. Comment, which is just a note in the program. A waypoint, a set, halt, and a folder. A folder would just be like a grouping over on the program. So if we click move, I'm going to get a new program. Okay, so if we click move, that puts a move J over here in the program. And we can go over to command, and it says move, which just means for every move you have multiple waypoints, which is just points to hit as it moves from place to place. And the way you set a waypoint is you get a waypoint, and then you click set waypoint, and you get this move screen. It's the same move screen that we saw before. You move the robot to where you want to go, whether you move the joints, you jog it up and down. Like, I'm going to click that, and we'll jog up. And you can see what's going on there is it's moving up, but it's not, it's keeping this parallel to the top of the part. And we can move it down. So you can set that waypoint, and by clicking OK, we're going to set that waypoint. And then it says add a waypoint after, so we can add a waypoint after, and we're going to set that waypoint. And this one, we could move it, we'll move it this way. and down. Okay. So we'll go here, we can go to the start of the program, we click play, we click auto, it moves back to that first waypoint, and then it's going to just do this. Those are the 2 waypoints we programmed, and it's going to just go back and forth till we tell it to stop. Okay, so we stopped the program and we're at waypoint 2. We can say move robot here, and we click auto. It's going to move to that second waypoint because that's what I had selected. And then what we're going to do is add another waypoint, but we're going to add a move L. So we'll go to structure and we'll click move, and we'll move that. Actually, we'll delete that. Click up here, move, and go to command. And then up here it says move J. We'll select that and click move L. So from waypoint 2 to the new waypoint, we're going to move L, which means move in a line, point-to-point line. So we'll set this waypoint, and we'll go like something like this. And we'll go like that. And then we'll move J, and we'll go, whoop. We'll just put it up a little bit, click OK. And we go back up to the top and we click play. It's going to ask us to move the robot into position and click OK. Now when we hit play, it's going to move to that second point. It moves in a line and then a move J back. So you can see it, basically that's, you do a bunch of those programming moves and you have the robot to do something. So at this point, let's say, after we get to point 2, or waypoint 2, let's tell it to open a gripper. So we go to set. Set is our input and output command. Well, it's more of an output command. So you can say set digital action, digital output to gripper 1, and we'll set that on, which means open. And when we get to waypoint 3, we'll tell it to close it. So we go set, and we can go digital output, gripper 1, off. Okay, so let's try that, see what that looks like. So you can hear that gripper opening and closing. So we'll stop that. We'll move to waypoint 1. And basically, you just build your program that way. There are advanced options that you can do. I don't think I've actually used any of these. This force one is kind of cool. You can have the robot apply a certain amount of force in pounds or kilograms, I would guess, and you can kind of get to a point in the program. What I was thinking about doing is using that to push down on a part in the fixture. I think I'm going to try that on my next job that I'm setting up. You get to your point where you want, and you push down with the robot to seat the part in the fixture, or to glue things together. You could have it push and hold the two things while they're drying or whatever. So that's kind of cool. The graphics shows all the moves that the robot does. It's not super useful, but it's kind of interesting to see all the different space it's traveling through. So, and the variables, if you have any counters or anything, they would show up here. And then in Wizards, those two things, the pallets and the conveyor tracking, are in here. I think the pallet is the most useful thing. I'll show you that. So the way the pallet works is you put that in, and then what it's looking for is, if you click this, it says a pattern. So you can have positions on a line, positions in a square, positions in a box, which would be 3 dimensions, or you can give it a list of random positions. You can see there are just a bunch of different spots. So the one I've used, it's like 2 dimensions, well, 1 dimension, 2 dimensions, 3 dimensions. It's the same concept, just sort of expanded upon. So if you click square, you get 4 corners. All you have to do is program each corner. So I have a 10 by 10 grid here. All I did was program the top of each part in each corner, and then you tell it down here, no, right here, you tell it 0.1 to 0.2 interval count. So I did this corner to that corner, and then I told it 10. So we just go in here and then type in 10. And then it will basically, as long as you have an equal spacing, which is very important, it will take this position, that position, and divide it into 10, and it will know the position of all those parts there. Then you do that for your other 2 corners, or your other 3 corners, and tell it how many are in between this corner and that corner, which would be 10, and then it knows the position of all 100 parts that are on that rack. That works too. It says you can change type, change pattern type. You do a box. Now you have 8 points, and you tell it, you know, how, let me guess, what are those 8 points? You'd have 4 on the bottom and 4 on the top would be your 8 points. And then how many parts are in that box. So if you had a box of cubes, you would have, say, 5 by 5 by 5, so 25 boxes of cubes inside of a box. Whoop. You would just program, you know, the top 2 corners, which would be 5 across there, 5 across, and then you'd have 5 high. You'd tell it that, and it would know the position of all the cubes inside that box. Then the pallet sequence, which is what runs when your pallet is called up. You get an approach, you get a move to the part, a move from the approach to the pattern point. That's a move L. It moves in a straight line. You get a set, and you can add to these, but you get the default, you get a set, so that's a close your gripper. A wait would be wait for your gripper to close, and then an exit move to get out of that position and move on to your whatever task you're doing. So we'll delete that. But that's kind of the core, in my opinion, the core of, if you're getting a robot to do something, you're going to have a lot of different parts that you want the robot to process, and how do you get them, without programming where each one's at, how do you get them into the robot's control? That's the key, and that's really easy on this robot. I don't have a ton of experience with other robots. I'm guessing it's probably maybe not as easy. Maybe it is, I don't know, but this is really easy. Let's see, anything else in here? So yeah, you have a wait command. The wait command is just, you either wait for a certain amount of time, or you can wait for a digital input to come on. So I use this, you can go in here and it says M54 mill end high. So when the mill is done processing, it sends an M54 M code in the CNC control, which activates a relay in the cabinet. I have a wire coming out of the robot controller going into the CNC cabinet, and it's just waiting for that relay to change state to a high or a closed. And then that's the only thing that is interfaced with the robot to tell it to load another part. That's really simple. I can kind of show you. I'll show you the robot running a part through, and then we'll probably end it for now. But let me know if you have any questions about anything, and I will answer them. Like I said, the moving the robot around is kind of, and doing some simple waypoint moves is really fun. I got this robot in around Thanksgiving last year, and I put it in my basement for probably a couple months, and we just had it bolted to a piece of plywood, and we play with it. Me and my son play with it for like a couple hours at a shot, and we just give it different move commands or mess with different palettes, palette setups to try to visualize how that all works, and figure it out. And it's just really fun. And I recommend you take a look at it if you have any automation needs. Oh yeah, let me see if I can. Oh yeah, we'll get that going. We'll get it moving. I'll show you what it looks like to stop the robot because you got in the way of it. So we'll get it moving here. And I'll just put my hand here. Wait. It does take a little bit of force, but you can see I bumped it, and then you get a protective stop alarm. All you have to do is click Enable Robot and then click Play, and then it takes off where it left. So we can do that again. So it takes a little bit when you're trying to do it. It seems like it takes a lot of force to stop it, but if it's swinging the base around, the robot base is pivoting, and this part kind of comes in contact with you, it doesn't take much force at all to stop it, which is nice because you can see it's kind of tight quarters here. And I'll often be working over here at the A, and this thing will be running. It sometimes bumps me in the back, but it just stops. So here's a view of the gripper assembly, kind of hard to see. Actually, I could rotate that. Stop. Move. Let me sit down here. So here's the setup that I came up with to load these parts. These are two SMC grippers. They are, the part number is MHZ2-10DN. It's basically the smallest gripper that SMC makes. I don't need a lot of holding force for this application, and my parts are small, so there you go. They each have an input well, they have two airlines going into them, depending on if you're opening or closing. It's a double acting gripper. The solenoid valve reverses that. These gripper pads, I don't know if that's the industry term, but that's what I call them. They screw onto the gripper itself, and they have a little machine profile that matches with the way the part is. That's the part you kind of gotta, you can kind of see in there. That's what you gotta come up with and sort of do on your own. I designed this mounting adapter to go from the robot, the end of the robot, to my grippers. It has this little end to press the start button, and it has a little horseshoe cutout to open and close the door with. I could automate the door, and I could tie into the cycle start on the machine, but I choose not to for a couple of reasons. I still have jobs that I need to load manually in the vise. So I want the robot to never control the machine without my knowledge. So having it actually go over and press cycle start is the most comfortable way of doing it that I feel. I don't want to be in there. Not, the door interlock works. I don't want to be in there or even have parts half loaded and I walk away and close the door, and for whatever reason an output goes high and the machine takes off. That's not what I want. So I want to always make sure that if the robot's going to start the machine, I'm going to see it go over and push the start button. So that's why I have it tied in like that. The other thing is you don't really have to mess with the mill. You just have one output to tie in. You don't have to get in there and mess with wires or do something that isn't a standard setup on a CNC machine. Other than the one output from the machine, the robot is controlling the clamping of the collet here. Only opening, it can only open it by giving a voltage out of the controller to the solenoid valve. It can't mess with it. It could mess with it if you have a setting in your program to open or close it when the machine's running, but the way I have it set up, I can't really do that. And sort of a caveat to that is I'm the only one that programs this mill. I'm the only one that runs the mill. If I mess with it, it's my fault. I don't have another machinist in here that could come by and mess with something and it's going to malfunction. So if you're in a situation where you have a lot of people around that would make changes to something and not tell anyone, or not, it might not be intentional or whatever, but you really need to think that through maybe a little more than what I have here on this setup. Well, I should say, if that part loosens up in that collet, I've done every conceivable mistake you can do on this. It doesn't, the world isn't over. It might break the tool that does the machining on there, no big deal. The part doesn't fly out of the machine, it just stays in there. It just doesn't really make a good part from a machining standpoint. So you got to kind of go through all those worst case scenarios. What happens if it drops apart? What happens if it doesn't clamp it? What happens if the gripper doesn't close in the right position? The beautiful thing about this machine is I was talking about the safety aspects and looking at those loads on those elbow motors or joint motors. It will stop if a part is not just so. If this part of the gripper hits the top of the part for some reason because the part's not in the right place, it stops. Whereas your more like heavy-duty industrial FANUC robots, my understanding is they're just going to go, and it'll smash parts. It'll just keep going and make sure it gets to the position. The great thing for me about these robots is they stop if something's not right. For instance, I had a chip on the end of one of these parts that was wrapped around where it grips. It picked it up and it went to put it in a machine, and since the chip was making the part go at a funny angle, it hit the side of the collet here, and it just stopped. And I think a normal robot might have just kept going, pushed something in, bent the part, bent the collet, just smashed it all up until it got to where it needed to go. It would have let go and started the cycle. Whereas this robot stopped, just sat there till I came over and was like, well, is the robot not running? Well, I looked in there, and the part was still in the gripper because it didn't get to the point where it could open it because it didn't get the part all the way in that collet. So that's really a benefit for me. It's sort of like broken tool detection on your mill. It just, you check each tool as you use it, and then you don't have any problems. Whereas each move of the robot, it's checking to make sure it got there without any abnormal forces. A really useful feature. So thanks for watching. That was my sort of overview of the UR5 robot from Universal Robots. Like I said, I'm very happy with it, very useful around the shop here. We're going to be buying more of them, just a matter of time. I recommend if you have an application where you're doing something over and over again, check them out. They're very easy to get started with. I don't think I had more than a couple hours of just figuring it out. Your sales rep in your area, look up who your sales rep would be. They'll bring a UR3 out, at least ours did. They'll bring a UR3 out and like basically train you before you even buy it. And then they give you, I think, a day of training with one of their engineers when you buy one. Since I played with it, I took it home and played with it before I used it. I never really followed up on the training, so I didn't take the training. Everything that I showed you is self-taught. There's a good manual that comes with it. It's enough to get you going. So very easy to get started with. I really recommend just, if you're going to get one, just get it and play with it before you even do the training. And then if you have questions, they can answer those questions instead of starting and not having played with it. You might not know where to begin. So thanks for watching. I'll talk to you guys later. Bye.